For problem number 2, the random variable x has the following discrete probability distribution. X values are 10, 11, 12, 13, and 14, and the probability associated with each of those x values are 0.2, 0.3, 0.2, 0.1, and 0.2. We notice that since the values that x can assume are mutually exclusive events, the event x less or equal to 12 is the union of the three mutually exclusive events, x equal to 10 in union with x equal to 11 in union with x equal to 12. Notice also that each probability is a number greater than 0, and if we add the probabilities, we get 1. So we know that this is a valid distribution for these probabilities. For part A, we want to find the probability of x less or equal to 13. So that probability, looking back at the distribution, less or equal means that the probability for the number 13 will be included because we do have the equal sign included for the inequality. So we're actually looking at the probabilities of 10 added to the probability of 11, added to the probability of 12, added to the probability of 13. So I've written out that statement. The actual probabilities involved are 0.2 plus 0.3 plus 0.2 plus 0.1, and that total is 0.8. For part B, we want to find the probability that x is greater than 13. So 13 will not be included. We could look at the table and say, well, greater than 13, the only other value greater than 13 is 14. And so the answer is 0.2. Another way to look at this is since all of the probabilities add to 1, we are thinking of the complement of 13. So 1 minus the probability of x less or equal to 13. So that would be 1 minus the probability of less or equal to 13. We just calculated that in part A. So that would be 1 minus 0.8. Again, the result is 0.2. So we have two possibilities to figure out the probability of x being greater than 13. For part C, the probability of x being less or equal to 11 means we are considering the probability of x equal to 10 plus the probability of x equal to 11. Looking at the table, less or equal to 11 means probability of 10 added to the probability of 11. So we would end up with 0.2 plus 0.3 equals 0.5. For part D, we're finding the probability of x equal to 11. So we go up to the table, equal to 11, we have 0.3. So we didn't have anything that actually needed calculating because of just the equal sign given. No inequality was given, so we're only looking at x equal to 11. For part E, we're looking for the probability of x less or equal to 12 or x greater than 13. When we see the word or, we're thinking the union of these probabilities. So we're going to add the probability of x less or equal to 12 to the probability of x greater than 13. Looking back to the table, less or equal to 12 involves the numbers 10, 11, and 12. So we'll add those three probabilities, and then the probability x greater to 13. In the table, the only value greater than 13 is 14. So we'll add another 0.2 for our probabilities. So we can see that individually we are adding the probability of x equal to 10 to the probability of x equal to 11 to the probability of x equal to 12, and then 0.2 comes from our probability of x equals 14. So we have 0.2 added to 0.3 added to 0.2 added to 0.2, and that total is 0.9. We have one more example of calculating probabilities using a discrete probability distribution. For this example, we are looking at NHTSA crash test. The National Highway Traffic Safety Administration has developed a driver-side star scoring system for crash testing new cars. Each crash-tested car is given a rating ranging from 1 star to 5 stars. The more stars in the rating, the better is the level of crash protection in a head-on collision. A summary of the driver's side star ratings for the 98 cars in the crash file is reproduced in the accompanying table. Assume that one of the 98 cars is selected at random and let X equal the number of stars in the car's driver's side star rating. So here's the table. The drive star rating of 2 through 5 is listed in the first column, and the count for each of those stars is also listed. The total number of the count is 98. So since we know the total, we can come up with the probability for each of the drive stars. A rating of 2 stars, there were 4 in the count. So 4 out of 98 will give us the probability. Notice in the table that I've started, I have a star rating of 1. We don't have any ratings of 1, so that probability would be 0. For a star rating of 2, that is determined by taking 4 divided by the total of 98. So I'll add a new column called probability. 4 divided by 98 equals our probability for 2 stars, and that is 0.0408. For a rating of 3 stars, we're taking 17 and dividing by our total of 98, and that equals 0.1735. Star rating of 4 would be 59 divided by our total of 98, and finally, star rating of 5 would be 18 divided by our total of 98. So we'll write all of these values in our table for an easy reference. Now that our table is complete, we can use the table to find the probabilities for the next couple of questions. Part B is asking us to find the probability of a star rating equal to 5. So X is our star rating. Looking right at our table, we can see that that star rating is 0.1837. So the probability of getting a 5-star rating is 0.1837. For part C, we're looking for the probability of a star rating less or equal to 2. So since equal is included, we're looking at the probability equal to 1 added to the probability X equals 2. So adding 0.0000 to 0.0408, that total is 0.0408. Our final question is wanting us to construct a probability histogram for X. So in the table, X values are the star ratings and P of X is the probability of X. So we'll begin constructing our histogram by drawing the axes. The vertical axis is the probability of X, and our horizontal axis is the star rating. So we have 5 different star ratings. So I'll label 1 through 5, and then we'll look at the probabilities range from 0 to the highest probability is 0.6020. So we need to make sure the scale we're using for probability can go that high. So each marking on the vertical axis will be worth a probability of 0.1. And then we'll draw the bars for the histogram. So we have 0% or 0.0000 for 1 star. 2-star rating is at 0.04, so that's even below the half tick mark. Star rating of 3 is at 0.1735. Star rating of 4 is at 0.6020, and finally a star rating of 5 is at 0.1837. And here we have our histogram. Whether you shade in your bars or not is up to you, but sometimes it's helpful to have the value of the bar written right at the top. So I'll go ahead and do that. And now our histogram is complete.